So this first question comes from Framework 1. Describe the combinations of transformations that take rectangle LION onto MATH. So L maps to M, N down to H. That's enough to see that it's a 90-degree counterclockwise rotation. So let's start with that and then see if there's a translation that also needs to be done. Well, 90 degrees counterclockwise rotation takes the point XY to negative YX. So this point L, which is at 210, is going to go to negative 10, comma 2. Negative 10, 2. So that's where L maps. It needs to then go down to where M is, which needs to translate 4 to the right and down 5. 4 to the right and down 5. So it's a 90 degrees counterclockwise rotation followed by a translation of 4, negative 5. B. This question is also from Framework 1. Which of the following will not map it onto itself? So we're looking for symmetry, rotational or line symmetry. So if you reflect across X, which is this line right here, that will not map onto itself. There's way more of the figure on the left than there is on the right. So that's what we're looking for, is which will not map onto itself. So reflection across X does not map onto itself. A 120 degrees clockwise rotation about the center. So if you rotate around the center, we're just looking for how many degrees it could rotate. Since there are 6 sides, 6 vertices that are all evenly spaced out, we take a full rotation of 360 divided by 6, and we get every 60 degrees it maps onto itself. Every 60-degree rotation. So that means if you rotate it 60, 120, 180, 240, 270, or 360, it comes back to itself. So 120 degrees will map onto itself. So we're going to cross that off because we're looking for which ones will not map onto itself. 90-degree rotation, that is not in our list, so that does not map onto itself. A reflection across Y does map onto itself. So 1 and 3 are the 2 answers that do not map onto itself. That's A. This question comes from Framework 2. And it's discussing vertical angles. Remember, vertical angles are those angles that are formed by 2 intersecting lines like this. Could be 2 angles that are across from each other, either left and right or top and bottom. So we're looking for rigid motions that explain why they are congruent. Well, first of all, we can reflect them over a line that cuts straight through the center like that. So that works. You can also rotate 180 degrees. That would map it onto itself. A translation would not work because they're facing different directions. It needs something to make them flip so they're facing the same direction. So translation does not work. A sequence of rigid motions. That just means you can combine a couple of different things, like you could translate it and then rotate it, or you could whatever sequence you want. It's very ambiguous right here. It's not specific at all. So a translation and then rotating it around and translating again, that would work. So there is a sequence that would map it onto itself. This question comes from framework 2. Given the segment xy, coordinates of y are 5, 8, and the coordinates of the midpoint are 1, 4. What are the coordinates of x, which would be the other endpoint? We could do this a couple of ways. You could graph it. If you want to pull out some graph paper, you could. You could plot those points. So we'd have 5, 8. And then the midpoint is 1, 4. And we're looking for point x, which would have to be over here somewhere, because that's, if m is the midpoint, it has to be in the middle of x and y. So you could get that. Once you have it graphed, you could just count and see. To get from y to m, you'd have to go down 4 and left 4. So you'd have to do the exact same thing to find x, down 4 and left 4. That would be point x right there. So that's negative 3, 0. You also can do it algebraically. Just take the midpoint formula. So we don't know the coordinates of x, you can call it x comma y. And you just take x plus x, so x plus 5 over 2 has to equal 1. And you would take y plus 8 divided by 2 has to equal 4. So you would multiply to get rid of the 2 in the denominator. So you have 2 equals x plus 5. Subtract the 5, you get x equals negative 3. Multiplied by 2, you would get 8. And then subtract 8, you get y equals 0. The exact same thing. So 2 ways you could do it. You could graph it or do it algebraically. This question comes from framework 1. Find the image of the shaded triangle if it's translated negative 3, negative 1, and reflected over y equals 2. So you can see that the shaded triangle in all 4 of these starts in the same place. We just need to figure out where the white triangle ends up. Which one has the white triangle in the right spot? So take the shaded triangle, translate it negative 3, negative 1. It would be right there. Then reflect over y equals 2. Oops, this graph is counting by 2, so let me start over. So if it's counting by 2s, you go negative 3. So negative 1, negative 2, negative 3, down 1. Negative 1, negative 2, negative 3, down 1. So since it's counting by 2s on our graph, we have to make sure that we count all the units, all the single spots that are supposed to be in between there. Then reflect over y equals 2. So here's the line y equals 2. If we reflect this, that's not far enough down. It would reflect to these 2 points. And that's the third point right there. So that's not quite far, or it's not quite the right spot. It looks like B down here is the one that's in the right spot. Yeah. From framework 2. Find the equation of the line that's parallel to x plus 3y equals 24. So let's start with that. Parallel means we're going to keep the exact same slope. So let's find the slope by getting it to be y equals mx plus b. So subtract the x over. And then get the y by itself. So divide by 3. You get y equals negative 1/3 x plus 8. The only part that matters is the slope, which is negative 1/3. We want parallel, so we're going to keep that exact same slope. We're going to use that negative 1/3. We just don't know the y-intercept. So we're going to solve for b. We can plug in the point that it has to pass through. We can plug in 2, 4. You could either plug it into slope-intercept form here, plug in x and y, plug in 2 and 4, or you can go to point slope form. Equals m, which we know is negative 1/3, x minus x1. So you have two options. You either plug it into slope-intercept and solve for b to get the y-intercept, or you plug it into point slope and just rearrange it. So if you plug it into point slope, you would plug in the 2 here. Then you would distribute and you have to add the 4 over. Since we're trying to add it to a fraction, you need to have a common denominator. So if you want a denominator of 3 that equals 4, that would have to be 12 divided by 3. Two thirds plus 12 thirds is 14 thirds. If you solved it out using the other equation, you still plug in 2 for x. So negative 1/3 times 2 is 2 thirds. And we plug in 4 for y. You end up with 4 plus 2 thirds, which was the exact same math we had to do right here. 4 plus 2 thirds, you get 14 thirds for b. 14 thirds for b. This question is also from framework 2. So looking at all lines that would have this type of equation, negative 3x minus a, you could distribute that even to make that become negative 3x plus 3a. That portion of the line, that's the slope. And that's the only thing that doesn't change, because a can change. A could be any number we want. You could plug in 1, 2, 3, even negatives. So the slope does not change here. They all have the same slope. Question from framework 3. LP is parallel to NM. LP is parallel to NM. So if those lines are parallel, that means we have alternate interior angles. So if you use those two lines to draw a Z shape, we created two angles right there and right there. So those two angles are congruent. These two angles are congruent. We also have LM, the top, is parallel to NP, the bottom. So we get a backward Z here, which creates these two angles, which are congruent. And then we have two triangles that share LN. So that's congruent to itself because of the reflexive property. So now when we go to name it, we have two angles and the side in between. That's angle, side, angle. Two angles and the included side are congruent to two angles and the included side. This is from Framework 2. We're looking for a correct proof. So if X and Y are parallel, that's given. 1 and 7 are corresponding angles. That's not true. They're not congruent and they're not corresponding. So that's wrong. X and Y are parallel, given. 1 and 2 are a linear pair. That's true. 2 and 8 are congruent because they're corresponding angles. 2 and 8, those are not corresponding angles. X is parallel to Y, given. 1 and 3 are a linear pair. 1 and 3, yes, that's true. 3 and 8 are congruent because they are alternate interior angles. 3 and 8, those are not alternate interior angles. They're not even congruent. X is parallel to Y, given. Angle 1 and angle 5 are corresponding angles. Good. 5 and 8 are vertical angles. That is true. And 1 is congruent to 8 because of the transitive property. We've used angle 1 and 8 already. We just linked them together with angle 5. That is the correct use of transitive property. So this is correct proof to show angle 1 is congruent to angle 8. This question comes from Framework 3. Determine the coordinates of the centroid. To find the coordinates of the centroid, there's a simple formula. x1 plus x2 plus x3 divided by 3. And then the same thing with the y's. So that's 1 plus 5 plus 3, which is 9 over 3. And then we do the same thing with the y's. So that's 1 plus 2 plus 9 over 3, 12 over 3. Both of those divide evenly, so we get 3, 4. The 0.34 is the centroid. This comes from Framework 3. And we're looking for what other statement must be true. So what information do we have to know that we don't currently know to prove the triangles are congruent by side angle side? So it needs to be something that's not given, written out explicitly right here. And it also needs to be something that is not obtainable from the picture. So vertical angles, that's basically given to you because it's vertical angles. If they share a side, that's given to you also because of the reflexive property. So you can, even if they don't list it, you know vertical angles, reflexive property, that sort of information. So you would not choose that because we already know that, because those are theorems that we know are true all the time. So JI is congruent to ST. You can go ahead and mark that. IH is congruent to TU. So we'll mark that. And we're looking for side, angle, side. So we have two sides. We need the angle in between, the included angle. The angle included between those two sides is angle T, STU. And angle I is the other included angle, JIH. JIH, STU. Those angles need to be congruent for side, angle, side. This question comes from framework 8. A golf ball with a volume of 33.51 cubic inches needs to fit into the golf ball cleaner. How big does the cylindrical opening need to be for the golf ball to fit inside? So we know the volume of the sphere, the ball, is 33.51. That's the volume. The formula for the volume of a sphere is 4/3 pi r cubed. We can take this equation, we can solve for the radius. So to solve for the radius, we're going to multiply by the reciprocal. So we're going to take 4/3, do the reciprocal, which would be 3/4. So we get 25.1325 equals pi r cubed. So now we're going to get rid of that pi by dividing. We'll just use 3.14 when we divide. So r cubed equals 8.004. Essentially, that's just 8, which is 2 cubed. So the radius is 2. If you didn't know that off the top of your head, I would just take the 8.004 and take the reciprocal power, do it to the 1/3 power to get r, which is 2. Now, don't be hasty and circle A, because that's the radius. That's not how big the opening is. It's only the radius. The opening has to be, you would measure that as the diameter, so it has to be at least 4 inches across. This question comes from framework 4. We have, if this is a parallelogram, to prove it's a parallelogram, there's multiple things relating to these angles. Angles that are across from each other, opposite angles, have to be congruent. That doesn't help us because we have an x and a y. The other piece of information about parallelograms is that consecutive angles are supplementary. So any two angles that are next to each other have to add to be 180. So if this angle is 40, the angles that are consecutive to it, right next to it, need to be 140 because they have to add to be 180. So now we have two simple equations. 8x plus 4 has to equal 140. Also, 7y plus 14 has to equal 140. So 140 minus 4 is 136 divided by 8. X equals 17. (140 minus 14 is 126 divided by 7. You get y equals 18. A. This question comes from framework 8. We have a container of iced tea mix with a radius of 4 inches and a height of 6 inches. Inside that container has enough powder for 12 full pitchers, 12 servings. And they want each scoop to scoop out the right amount of powder. So you find the total volume of this cylinder, pi r squared times the height for volume of a cylinder. So that's pi times 4 squared times 6. Do 3.14 times 16 times 6. We have the volume of that cylinder is about 301.44 cubic inches. And that's supposed to create 12 full pitchers. So divided by 12 means that we want a scoop to equal about 25.12 cubic inches. So now we just check each of these volumes for these scoops and see if we get 25.12. So a cylindrical scoop, that's pi r squared times the height. So 3.14 times the radius squared, which would be 4, times the height, which is 2, and you get 25.12. So that one works out perfectly. A cone-shaped scoop, so that's same as the volume of a cylinder, just divided by 3. So it's pi r squared, 3.14, times 4 squared is 16, times the height is 3, and then it's a cone, so we divide by 3. That's 50.24. That's too big. A square pyramid with a base of 4 and a height of 3. Pyramid is the area of the base, so 4 times 4 is 16, times the height, which is 3, and then it's a pyramid, so you divide by 3. So that has a volume of 16, not 25.12. And a rectangular prism, that's 3 by 2 by 2, that has a volume of 12, not 25.12. So only scoop A of those options would work.